Hi, today we're going to learn about the quotient rule of exponents. Our goal is I can simplify exponents using the quotient rule. Feel free to pause the video as often as you need. So when we first learned about exponent rules, we learned about the product rule, we already learned what x to the power of 5 means. X to the power of 5 just means x times x times x times x times x, where you write that x 5 times because it's to the power of 5. We wrote an x because the base, right, this big font number, is an x. Now notice that I did not write all the dots in between each of these x's. You can if you want to though, but sometimes multiplication is an invisible operation. Now this dash or slash line right here means division. It also means a fraction. So it can also be written like this. And we know that x squared, or x to the power of 2, just means x times x. Now it asks, what does it simplify to? Well, anything divided by itself, because remember this, it could mean a fraction, but it also means division. So we're doing x divided by x. Well, anything divided by itself equals 1. And then when you multiply 1 times x, well, it doesn't change anything. So sometimes we use the vocabulary cancel out. So x divided by x cancels out because it really becomes a 1 and that doesn't impact multiplication. So again over here, x divided by x cancels out again. So all we have left is x times x, which means we have x to the power of 3. So our next question is, well, what's a faster way to simplify that? Because yes, you absolutely can write the whole thing out and figure it out. Great strategy. But if you want another way, we remember that the answer was x to the power of 3. How can we use the numbers 5 and 2 to get a 3? Well, 5 minus 2 is 3, so we can subtract. I should specifically say we can subtract the exponents when the bases are the same. So this right here is that base, and because these are the same thing, that's why we're able to cancel out the x on top and bottom, because x divided by x is a 1. So if they were different letters, then you can't simplify it. But when the bases are the same, subtract the exponents. So here we have our quotient rule of exponents. You might see it written like this as a fraction. You might see it written like this with a slash. You might even see it written like this with an actual division symbol. They all just mean the same thing. They all mean what we looked at 2 slides ago, right here, where you're able to divide top divided by bottom and cancel it out. And remember this, subtracting the exponents, the top exponent minus the bottom exponent, yes, that matters. Has to be the top one first minus the bottom one. That only works when the base is the same. So let's do some practice. Here, very similar to what we just did, 5x's on top, 3x's on the bottom. For this example, go ahead and write it out just so that we can have kind of a visual when we look back at our notes. 1, 2, 3. And now there's 3 of them that'll cancel out on the top and the bottom, or that can divide out on the top and bottom. And we only have 2 x's left, so that's why we got x squared. Over here we have an invisible exponent, okay? It's an invisible 1. And the reason that this still works even though the exponent is invisible is because we've got our 4 y's on top and we have a y on the bottom. So it counts as 1 y. Those cancel out, those divide out, and we have 3 y's left. Now we have something a little more challenging. We need to separate this into 2 parts. We're going to separate this into the fraction, 15 over 3, or the division problem, 15 divided by 3, and the fraction, or the quotient, z to the 7 over z to the 4th. So here again we have those split into 2 things, our fraction, and here's our shortcut. We've subtracted the top one minus the bottom one, 7 minus 4, to get z to the power of 3. Now the reason we split this up is because the numbers here, they're called a coefficient. This coefficient does not have an exponent, like it doesn't say like, oh, squared or something like that over here, okay? Excuse me. And because it doesn't have that coefficient, it does not have to worry about those exponents at all. And then 15 divided by 3 is just the number 5, so that worked out great. Now over here, our base is the number 4. It is okay to have a base that's 4. What's not okay is that this base is a 3. So we cannot simplify this because the bases are different. If the bases had been the same, let's say it was 4 to the 5th over 3 squared, oh, I already did that wrong, over 4 squared, well then, it's 4 times 4 times 4 times 4 times 4 on top, and then 4 times 4 on the bottom, and you can cancel them out, so it just becomes 4 to the 3rd power. Notice how this is different than this, because over here, our previous example, the exponent was not on the coefficient, so that number stayed, that number was able to change with our division problem. But over here, because the exponent is on the number, this is not a coefficient, it's the base. And it just stays exactly the same. We're not going to do any division. 4 divided by 4. And as a reminder, the base is the variable or number that the exponent is attached to. Thanks. Bye.